The topic addressed by this scenario is too big and too far, the solar system scales, and we are using Plickers to help us discuss and inquire the students about the preconceived knowledge about these topics. And you can then start your lesson. So there is a specific scenario without the tips and tricks for Plickers, where you will find this slide that I'm presenting here. And this is a slide that is a provocative one to trigger the conversation about the size scales. Usually, textbooks do not present the correct size and distance scales related to the solar system. They are usually completely wrong. And by the end of this lesson, you and your students will be able to understand why this happens. So this is a typical picture that we would see in a book or a magazine. Even space agencies usually use images like this. Although they are very beautiful and the images per se might be very realistic, there is something very wrong with the distance scale and the size scales of the solar system main bodies. So you start with a question to your students using Plickers about what this image actually represents. So you ask, does this image represent the real distances and sizes of the sun and the planets? And your students will have to choose between 4 different answers. Yes, it's totally correct. Or the size scale is correct, but the distance is not. Or the distance scale is correct, but the size is not. Or both scales are wrong, which is indeed the correct answer. Both scales are wrong in that picture. So after you've presented the previous question, you can also ask your students, if the Earth were the size of a grape, like for instance 1 centimeter, how big would the sun be? It's just to spark, to ignite the conversation about this business of the size, the scales of the sun and the other main bodies in the solar system. You would be surprised with the answers that you will find. And then, of course, you present the reality, and this is a very nice image that you can use. That shows that the sun is about 109 times the diameter of the Earth, which is really, really very huge. And in this image, we are pointing to the Earth, and you can see the very tiny moon over there. And this is the correct scale in terms of sizes of the sun and all the rest of the planets of the solar system. And this is a very important image. I think it helps students understand our place in the universe, how small we are, taking into consideration how big is just the solar system, which is one star among billions of stars in one galaxy among billions of galaxies. But let's continue the journey. This slide is to discuss which is the planet in the solar system that has a similar size to the Earth. And of course, this will ignite conversations about, oh, could we live there if it is the same size? Maybe it has the same conditions that we have here in our planet. Of course, the answer is Venus. And we will very soon see why it is not possible for humans to live on Venus. So you can show here in this image that they are similar in size, but they are totally different in terms of characteristics that they possess. You can see here, for instance, the temperature on the right of the different planets, the average temperature. You see that on Earth we have something like 15 degrees Celsius on average, while in Venus we would have 464 centigrades degrees. So it's really not very comfortable if you imagine that you would live there. Also, you can see that in terms of atmosphere, neither Venus or Mars could harbor life as we have it here on Earth, because they don't have the atmospheric composition that is friendly to life as we have here on Earth. Okay, now is the time to start speaking about distances in the solar system. And so to tease them, you can have them imagine that the Earth has the size of a grape and that it's placed 1 meter away from the sun, that has the size of a melon. You can actually take these fruits with you so they can visualize it. And you can ask them, how far would Neptune be? And the answer is 30 meters. We are using a meter here as if it was what we call an astronomical unit. It's the distance between the Earth and the sun. And they will have a sense of, wow, this is really big. If we think that, we have to walk 30 minutes to reach the end of the solar system, if the Earth has the size of a grape and the sun has the size of a melon. And they will be intrigued by that. And the next question is for them to consider which is the true distance about the distance between the planets. Are all planets evenly spaced? So if they realize that Neptune is at a distance of 30 meters in that particular case we are using, how do they distribute the other planets? And you can have them do this activity in the classroom, create groups, and each of them will have a different vision on how they are distributed. And you give them 3 options. All planets are evenly spaced, inner planets are close together, and outer planets are very far apart, and all planets are very far from the sun. And then you can reveal to them the real distances and show that the inner planets are close together, very close to the sun, and all the other planets are very far apart. You can then present the reality for them. You can see here all the rocky planets, as we call them, which is Mercury, Venus, Earth, and Mars, are very close to the sun. And then Jupiter is far, and then Saturn, Uranus, and Neptune. So this is a good representation of the distance of the planets. So of course here you have 2 different scales to represent the distances and another scale to represent the sizes. And they will now ask you, why do we need to use 2 different scales? If we want one scale, if we are representing the comparison of the size between the Earth and the sun, and another scale if we are comparing the size in distances in the solar system. And you can show, for instance, this is the distance between the size scale between the Earth and the sun. Indeed, this is how small our planet is compared to the sun. But if we use the same scale and we try to put the distances, we will have to go really, really very far. And to help you with that, there is an information with in kilometers about the diameter and also in kilometers about the distances. You will immediately see how difficult it is if you use the same scale for both. You would need a really big town to place the sun and have the Earth using the size, different scale, and then put the planets in order. You will really need to go very, 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 very far away. And so these are important discussions that you can have with your students. You can explain to them that if you use the same scale, the planets become invisible dots, or the distances becoming practically long. And this is an introduction for them to understand that the universe is immense. And we should appreciate our blue planet, this beautiful planet that you see behind the astronaut. And by the way, this is a real picture of an astronaut around the International Space Station. And you can also quote Carl Sagan in the episode of Cosmos called Pale Blue Dot, where he says very beautifully that the Earth is the only home we have so far. I hope you appreciate this scenario. It's just a simple scenario, but you will see by using it how effective the use of Plickers will be when you're using this scenario.